In question number 16, a ray of light travels from a medium of refractive index 2 to air. Its angle of incidence theta and angle of deviation delta is measured and plotted as shown. So we have to check the validity of given options. So at theta is equal to theta 1, the deviation changes from this value to this value. So we can say that it is the point of TIR. So if the ray moves from denser medium to rarer medium, and at this angle if I calculate the critical angle, then the value of critical angle IC is equal to 1 by mu. So that is equal to 1 by 2. So from here critical angle or theta 1 comes out to be 30 degree. So if angle of incidence is slightly greater than the critical angle, at that moment the value of delta naught becomes this. So we can say that at that instant, if suppose this is the angle of incidence which is greater than critical angle, then TIR occurs and ray moves in this direction. So we can say that the deviation delta becomes, or delta naught is 180 degree minus 2 times IC, so that is 60 degree. So it comes out to be 120 degree. So option B is correct and C is wrong. So we know that for angle of incidence greater than critical angle, delta is 180 degree minus 2 times theta, where theta is the angle of incidence. So if I take the derivative of this with respect to theta, so it comes out to be minus 2, and from here if this is alpha, this is 180 minus alpha, so this is also equal to slope minus tan alpha. So from here the value of tan alpha comes out to be 2, alpha is equal to tan inverse 2. So option D is also correct. So the correct answer for question number 16 are option B and D. Let's move to question number 17. In question number 17, two identical smooth spheres A and B are free to move on a smooth horizontal table. Coefficient of restitution for the collision between the spheres is half. A is projected with speed v0 towards B as shown. After the collision, we have to check the validity of given options. So at the moment when this make a collision with the sphere B, its center is this point, its center is this. So if I join this center, this is becomes 2r, this is r, and let this angle is theta. Then sin theta is equal to perpendicular r by 2r, so it comes out to be half. So the value of theta comes out to be 30 degree. So at that moment, if I take the velocity of A along the direction of line of collision, then it would be v0 cos 30 degree, that is root 3 by 2, and in this direction its velocity is v0 by 2. So this is the velocity of A. So before collision the velocity of B is 0. So after collision, let the velocity of A in this direction is v1 and the velocity of B in this direction is v2. So the component of A in this direction remains unchanged, that is v0 by 2. So if I apply the principle of conservation of linear momentum along the line of collision, then I can write m into v0 root 3 by 2 is equal to m into v1 plus m into v2. This is my first equation. And if I apply the Newton's law of collision along the line of collision, then half is equal to minus v2 minus v1 divided by u2, that is the velocity of second particle before collision, 0, minus velocity of first particle before collision is v0 root 3 by 2. So if I solve this equation for v1 and v2, the value of v2 comes out to be 3 root 3 v0 by 8, and the value of v1 comes out to be root 3 v0 by 8. Let's check the options. The speed of B is 3 root 3 v0 by 8. So option B is correct and A is wrong. Now I have to check the validity of option C and D. Velocity of A is perpendicular to its initial velocity. This is possible when the collision is elastic. Since the collision is inelastic, so option C is wrong. In option D, velocity of A after collision is. So velocity of A after collision would be v1 square, that is 3v0 square by 64, plus the component of A in this direction is v0 by 2 whole square. So that is v0 square by 4. So if I solve this, it comes out to be under root 19 v0 by 8. So option D is also correct. So the correct answer for question number 17 are option B and D. Let's move to question number 18.